All right, so welcome back to part two of the Panacetin laboratory. And we said that the first component of this drug that we're going to give you in the lab is sugar, which we can call sucrose. And we are supposed to take sucrose and we are supposed to pull it out of the pill or the mixture that you're given and quantify it. So, meaning we need to calculate how much percentage-wise is sucrose based on the weight. All right. So the next part or the next structure that I want to talk about or component is the structure called aspirin. Aspirin. I know my chicken scratch is a little horrible and you can't read it sometimes, right? But aspirin is the shorthand layman term. This is what everyone knows it as if you go and talk to just someone off the street. However, aspirin, if it's the common name, it must have an actual chemical name as well, and it does. And the chemical name is acetyl, A-C-E-T-Y-L, salicylic, S-A-L-I-C-Y-L-I-C, acid. Acetyl salicylic acid. And we abbreviate this as ASA very often in a laboratory because we're too lazy to write the whole word down. All right, so acetyl salicylic acid, you know as good as well as I do what it does, right? This is classified as a drug, but it's an over-the-counter drug, meaning that I can just walk in to a pharmacy or to a grocery store or to Walmart or Target, some type of super center, and buy it straight from the shelf. So it's over-the-counter, and it's used to treat pain. It's used to treat fever, and it's used to treat inflammation. So very often if I have a headache, well, that's probably pain that I'm suffering, and I can take aspirin and it will help it out. Or if I stub my big toe and I have a big toe ache for days on end, then I can take an aspirin pill and it will be okay. Fever, if I'm sick, I will often get a fever. And that's okay because that fever is what's killing off the bacteria and all of the nasty viruses that might be inside of your body. So that's a very good sign. But some people get too hot and they can't stand it and it makes them grumpy and irritable. So they can take an aspirin and it will lower their fever down and it will lower their inflammation down too. Believe it or not, when you cut yourself and it sets up pus, that pus is kind of good because that's dead crap that you're not getting inside of you anymore. So as long as you don't let the pus kind of hang out forever, you're going to be okay. That's kind of your body doing what your body needs to do. Aspirin is also a blood thinner. So very often later on in your years, you will probably get very high blood pressure. It tends to at least trend high the older that you get. And that very high blood pressure can be fixed sometimes with just a simple little blood thinner. And that blood thinner literally makes your blood thinner. And it allows it to circulate through your arteries and your veins a little bit better, and your blood pressure goes down because of it. The issue is that, it prevents heart attacks and strokes, but at the same time, if you cut yourself, you become a free bleeder, meaning that it's very hard for you to stop bleeding when you do get a cut or a scrape or a wound. And for that reason, a lot of the older population of people that are on blood thinners, when they hurt themselves, they will bruise very easily. Or if they cut themselves, it will be very hard for them to stop the bleeding from a simple little cut. And it's due to these blood thinners, medications, or just baby aspirins that the doctor tells them to take every day. All right. Acetyl salicylic acid. It comes from salicylic acid. This is kind of the precursor that was used back in the day. And the reason is because people knew that if they went and chewed on willow tree bark, that all of a sudden the pain went away. So if they had an achy little tooth, they would go and chew on some bark of a tree, and word got around that, hey, this stuff actually kind of works. So what's in the tree bark that allows the pain to go away? And what they found and discovered is that it's this compound called salicylic acid. However, the problem here is that salicylic acid works too well. It's too potent for you to take it all the time. And what does that really mean? Well, that means that if I took it and I did it a couple of days in a row, and that's all that I want it to do, I would actually set up internal ulcers, and I would get internal bleeding in my stomach. And the reason is because this pill works too well. So internal bleeding is a no-no. Ulcers are a no-no. And we have to deactivate it. We have to make sure that when people take this, they can't really overdose on it. So what they decided to do is that they decided to go through and add the word acetyl, or the group of acetyl, onto the chemical structure. And this is how we get acetyl salicylic acid. So acetyl salicylic acid, well, this did not have really as many side effects. You can still overdose on it. It can still give you ulcers. You can still get bad things from taking too much aspirin, don't get me wrong, but it's not as potent as salicylic acid is. All right, so it's much safer to use in the hands of a general consumer. So what happened is that the company Bayer took the recipe and they ran with it. And they started producing acetyl salicylic acid, and they made millions and millions and millions of dollars off of this one pill. And they're still making millions and millions of dollars off of this pill. So something as simple as that, looking at an old wives' tale, taking willow bark, extracting the salicylic acid, and modifying it to weaken it, not to make it stronger. And Bayer took advantage, and now they're sitting pretty. All right, so the structure of aspirin, what does it look like? Well, we have a ring structure that's involved here. And this ring structure is a benzene ring. And off of this benzene ring, we have a carbon that kind of sits up here to the top. And that's double bonded to an oxygen. And then over on this side, we see an OH group. You kind of saw this with benzoic acid, right? It had very similar characteristics. But this is only part of the acetyl salicylic acid structure, or aspirin structure. So I'm missing another piece, and this other piece is the acetyl part. So acetyl in chemistry means two carbons. That's what this term means. Whenever I see acetyl or acetate, it's representing two carbons. So off of this ring, right beside of this COOH group, I see another bond that goes to an oxygen, and then this is attached to a carbon with a double bond O, and that's attached to another carbon. There's my two carbon chain. Right there is number one. Right there is number two. So salicylic acid and acetyl salicylic acid, well, this kind of stuff is very common. It's very common to sodium benzoate as far as the structure goes that you did in the very first lab, but there's slight differences between the two compounds. Well, if you take a look at the structure, what you will find out is that this structure does have some polar groups on it. I see an OH group, I see an O group, I see a double bond O that's here, I see another oxygen that's there. So there is polarity associated with the aspirin. Not as much as the sugar, right? The sugar is loaded down with them. This one, though, it's got a few, but it also has this big chunky ring that doesn't have any polarity at all on it. All right, well, aspirin, it is soluble in water, just like sugar is. And aspirin does have a melting point. We can do the melting point. It doesn't decompose on us. And that melting point is 135 degrees Celsius. So if I take pure aspirin in the laboratory and I put it on a melting point system, that melting point system should give me 135. Okay? So that's a little bit about the structure of aspirin. Now, what about aspirin? What can we say about it? Well, here's some pictures of some old-fashioned bottles of aspirin tablets. Over here to the side to the left, it says Bayer's aspirin tablet. Dose 1 to 2 tablets with water, used in the following conditions: headache, cold, sciatica, if you've got some back problems, toothaches, basically any type of pain that you might see. But here's the old school bottle of a Bayer aspirin. They also sold them in tin cans. Here you'll see them in the center. 10 cent. 10 cent, you get your aspirin. Imagine buying anything for 10 cents now. And then over here to the left, you'll see another advertisement about aspirin, and it says, say Bayer when you buy aspirin. Insist it. So this was their way of making sure that their branding stayed true, right? They wanted you to associate aspirin, which is a miracle drug, at least that's what some people believe, with the word Bayer. Okay? So they call it genuine. They call it the only aspirin that's out there, and that's the one that you need to purchase. All right, so in the next video, we're going to talk about our third component. And the third component, we know what it's supposed to be. The issue, though, is that it might not actually be there, because that's the purpose of the lab. Part 2 of this lab, identifying the unknown component, is basically going to walk you through whether or not they're telling you the truth on this third component. So we'll talk a little bit about the next one in the next video.